Hello guys, welcome to my YouTube channel. Today we are going to see about display list and modeling. So why display list? The computer would send out the necessary information to redraw the display at a rate sufficient to avoid noticeable flicker. So where we can see the flicker. Imagine in the olden days when we have flickers in the TV. The data which we are getting will not be sufficient, or the rate at which we are getting it is not sufficient. So we can see flicker like a single line in the screen or multiple lines which will block some data or some waves. So that is called flickering. In the past, since computer was slow and expensive, the cost of keeping an even a simple display refreshed was prohibitive for all but a few applications. The solution is to this problem was to build a special purpose computer called a display processor. So, since in the olden days the computers were costly, so keeping a refresher for the display is even more costlier. So many people wouldn't use that. But later development in technology provides lots of new solutions like display processor. We can send graphic entities to a display in one of the two ways. Send the complete description of our object to the graphic server. For a typical geometric primitive, this transfer consists of sending vertices, attributes, and primitive types in addition of viewing information. So the first way can be we into the graphic server we have to send everything like vertices, attributes, primitive types to get a flicker less output. And another way is define the object once, then put its description in a display list. The display list is stored in the server and redisplayed by a simple function call issued from a client to server. Means create a list or a display list in that store all the vertices, attributes, and primitive types. So whenever we want to redisplay that list, we can just simply function call that function, that display list, and we can get the same output. This is more faster than the first type. So display list have many things in common with ordinary files. OpenGL has a small set of functions to manipulate display list and places only a few restrictions on display list contents. OpenGL really made it easy to use the display list and we can manipulate the display list as well. So how to create a list? So we know that by calling a function to the display list, we can get a flicker less or less flickered output. So how we have to create a list? So in this example, you can see I created a polygon of four sides. So first I'm going to define a constant called box1. Means this is the one box I have. Box is the name of the constant and one is its value. And I'm going to call the function gl new list. This will send the list to the server but not to display its contents. This function gl new list will contain two parameters. One is box and one is gl compile. Next I'm going to begin with the gl polygon. So that is going to start with gl begin inside the bracket gl polygon. Now I'm going to give the color of this as red color. So I'm going to give 1 comma 0 comma 0. So it will have four sides. So that's why I'm using gl vertex 2f four times here. You can see minus 1 comma minus 1, 1 comma minus 1, 1 comma 1, minus 1 comma 1 is what I use to define the polygon. I'm going to end this with gl and I will end the list with gl end list. So definition and execution of display list. The OpenGL stack data structure can be used to keep the matrix and its attributes at the beginning of the display list. So, a simple stack will be used to keep the matrix and its attributes of the display list. So, I'm going to use GL push attribute. Inside that GL all attribute bits. So, I'm going to create a stack and um, in which it will follow the first in first out, sorry, it will follow the last in first out, and I'm going to push all the attribute bits inside that. I'm going to push the matrix into the stack of a matrix using GL push matrix. After the execution of the attribute, I'm going to pop those attributes using the function GL pop attrib, and then I'm going to pop the matrix from the stack of matrix using GL pop matrix. If you are not sure about which number to use for the list, use GL gen list. This returns the first integer of a number, consecutive integers that are unused labels. The function GL call list allows us to execute multiple display lists with a single function. Each time we wish to draw the box on the server, we execute the function called GL call list, comma box inside that box. Note that the present state of the system determines which transformations are applied to the primitive in the display list. Thus, if we change the model view or projection matrix between executions of the display list, the box will appear in different places or even with no longer appear. Example, GL matrix mode, GL projection for I is equal to 1, I is less than 5, I plus plus, GL load identity, GL ortho 2D minus 2.0 multiplied by I, 2.0 multiplied by I, comma minus 2.0 multiplied by I and 2.0 multiplied by I, and we are going to call this list using GL call list inside that box. Every time that the GL call list is executed, the box is redrawn with a different clipping rectangle. So if the present state of the system determines the transformation applied to the display list, then the changing the model view or projection matrix between execution will make the box to appear in different places in the screen, or it may be appear or it may not be appear. Both are the possibilities. And the GL call list is used to call the function or the box on the server. The box will always be redrawn with different clipping rectangle call. That's it for today, guys. Thank you.